This video will be about volume. When you're looking for the volume of a figure, we're looking at three-dimensional figures and we're trying to figure out how much would fit inside the figure. Maybe we have a cylinder, like a soda can, and we're trying to figure out, well, how much soda is inside that can. So there's a whole bunch of formulas that go with a whole bunch of different shapes. You do not need the formulas memorized. They are provided on a reference sheet when you take the exam. The first shape is a cone. Our cone has a circular base and then one point at the very top called the vertex, where you go from one side of the circle to the vertex and then the other side of the circle to the vertex. Your cone has a radius and a height. The height goes from the vertex to the center of the circle. So if our radius is 4 centimeters and our height is 9 centimeters, we would plug it into the formula 1/3 times pi times radius squared times height. Radius is 4, so 4 squared. Height is 9, so times 9. If this is asked to be left in terms of pi, then you only multiply the numbers that are not pi. 1/3 times the 4 squared times the 9. So 1 divided by 3 times 4 squared times 9 is 48. Pi would still be part of the answer. And then we would use our units, centimeters cubed. Where squared worked for area, cubed is for volume. So we could also say this cubic centimeters. Now let's look at our cylinder. So cylinder is pi times radius squared times height. Let's say they give you the diameter this time. So in our pi times radius squared times our height, we have to find our radius. Diameter goes all the way across the circle, and radius is only halfway across the circle. So 10 divided by 2, because we have to cut it in half, is 5. So we use 5 squared times a height of 18 inches. This time let's approximate the volume. So we can use the pi button on a calculator, or you could use 3.14. The pi button is the better option if your calculator has it. So then we get 1,413.716. They can ask different places to round. Let's round to the nearest whole number. So 1,414. And this would be inches cubed. Next we have our pyramids. So the formula for a pyramid is 1/3 times a big B. The B is the area of the base times the height of the pyramid. So the pyramid is kind of like a cylinder or cone where you're going down from the vertex to the center of the shape, and that's your height. The base depends on how the pyramid is drawn. On our first pyramid, we have a triangular pyramid. On our second pyramid, we have a rectangular pyramid. So on this first one, we need to know the area of a triangle, which is 1/2 times the base of the triangle times the height of the triangle. And on this one, we need to know the area of a rectangle, which was length times width. So for each pyramid, this would be incorporated where it says B. So for this first pyramid, we would have 1/3 multiplied by this area formula, so times 1/2 times base times height, times the height of the pyramid itself. So sometimes we switch up how these were originally labeled so we don't end up with two of the same letter. I'm going to call this base, and I'm going to call this length instead, times the height of the pyramid itself. Or for this one, we would have the 1/3 times the area of the base, so times length times width, times the height of the pyramid. Next we have all of our prisms. So the area of a prism, again, depends on the shape of the prism. If it is a rectangular prism, we have length times width times height. If we have a different shaped prism, again we go with area of the base. The big B is area of the base. So the base is the shape that is then just connected by a straight line to its duplicated shape. We have a triangle here, this is the base, and it's connected by straight lines to another triangle, the other base. So again, we need to know the area of the shape we're actually working with. Area of a triangle is 1/2 times base times height. Again, we're running into this issue where we may end up with the same letter. So we do have to know what's applying to what. I'm going to call this base, and instead of height, again, I'm just going to call it length to give it a different variable. So 1/2 times base times length times the height of the prism. Or on our trapezoid prism, we would need the area of a trapezoid. 1/2 times the height times base 1 plus base 2 times the height of the prism. We're running into that same issue. Just make sure you know what each of those letters actually mean. We have a sphere. The volume of a sphere is 4 divided by 3 times pi times radius cubed. And the radius goes from the center of the sphere to a point on the outside. Usually we just go directly to the right. It really could go straight up or at an angle, but usually it's just labeled from the center to the right side of the sphere. So let's do some example problems. Chris wants to ship a package that has a volume of 1,800 cubic inches. If the length is 15 inches and the width is 10 inches, then how tall would the box need to be? Now they didn't specify, hey, this is going to be a pyramid, or hey, this is a cone. But they did say this is a box. So a standard box is a rectangular prism. So if we have a rectangular prism, and they said the length is 15, width is 10, and the height we don't know, but we do know the total volume is 1,800 cubic inches. Well, if it's a rectangular prism, the volume for that was length times width times height. And we aren't plugging in for L, W, and H. We're plugging in for V and L and W. Almost always we're using just the L, W, and H and finding the volume. This one's set up a little bit different. They gave us the volume, gave us the length and the width, and then we're finding the height. So we have 1,800, and we can simplify a little bit. 15 times 10 is 150. Times the height. Then we can do the opposite of multiplication. If this is 150 times h, we divide by 150 to find the height. So 1,800 divided by 150 is 12 inches. The second question, a cylindrical pitcher has a height of 20 centimeters and a diameter of 8 centimeters. If the pitcher is 2/3 full of apple juice, what is the approximate volume of the liquid? So cylindrical means we're using our cylinder. They told us the height was 20 centimeters and the diameter all the way across was 8 centimeters. And then they said it's only 2/3 of the way full. We actually only have liquid 2/3 of the way up. So we do have to find the entire volume first. Volume of a cylinder was pi times radius squared times height. Radius would be the diameter divided by 2, or 4. If they already give the radius, you don't have to do this step, but if they give the diameter, we do have to divide by 2. So times 4 squared times a height of 20. Now it did say to approximate, so we will use the pi button. Pi times 4 squared times 20 is 1005.3. Let's approximate to the nearest cubic inch, so just 1005. Now that's the entire volume. It said that the pitcher was only 2/3 of the way full. If they ever provide a fraction like that, all you need to do at the end is multiply the entire volume by that fraction. So we're going to take our volume and multiply by the fraction 2 divided by 3. Remember that fractions are just division problems. This bar is saying you're really doing 2 divided by 3. So 1005 times 2 divided by 3 is 670.2. Again, if we approximate to the nearest cubic inch, that is, or sorry, centimeters in this one, that's 670 centimeters cubed. One last problem. A pyramid is inside a cube as shown in the diagram below. So a cube is like a square compared to a rectangle. A square means all 4 sides were the same. Well, on a cube, all of the dimensions are the same. If they label 1 8, everything else is 8. We really only need the length, width, and height, though, of the cube. If the base of the pyramid is one face of the cube, so they're saying the base of the pyramid is this entire bottom face of the cube, and the vertex of the pyramid hits the center of the parallel face, so the vertex is in the middle of the top square, what is the volume of the space between the cube and the pyramid? So a cube is just a version of a rectangular prism, where all the sides are the same. So we're still going to use the length times width times height, but we do 8 times 8 times 8. So volume would be 8 times 8 times 8, or 512. So that's the volume of the cube, and we can put the units on it as well. Then we need the volume of the pyramid. Well, the pyramid, we needed the base of the pyramid and the height of the pyramid. Volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. Well, on a pyramid that has a rectangular base, area of a rectangle is length times width. So the length and the width would be the 8 and the 8 again. 1/3 times 8 times 8. The height is going from the center of the top face to the center of the bottom face. So the height is actually going to be the same as the height of the cube. So 1/3 times 8 times 8 times 8. We've already done the 8 times 8 times 8, so I'm just going to say times 1 divided by 3, or 170.7. That was the 666 repeating rounded. So now to find the entire volume that we are asked for, we're going to subtract those two volumes. 512 minus the 170.7 is 341.3 centimeters cubed. And I should have specified where to round. I rounded to the nearest 1/10. It will specify in the problem, or you can look at the multiple choice answers and see where the answers have been rounded. So that concludes our discussion of volume.